Hello guys, welcome to another episode of Cuda Education. Today we're going to talk about some topics related to the Vulkan API. Okay, so my latest tutorial, which is tutorial number 7, goes through a couple of things that I'd like to generally discuss here. So in Vulkan and in computer graphics, you have a thing called the viewport. So a viewport is generally, in layman's terms, it's a window that you see on the screen. So it's your window that you see on the screen that things are being displayed to. So you have a viewport, which is like your computer monitor. And then within the viewport, you might have a thing called a scissors. And what a scissors is basically the region of the viewport that the pixels or whatever Vulkan generates is saved and displayed on the viewport. So whereas this is the viewport, the scissors might just come up to here. So the image might be this, the image might be the whole screen, but the scissors cuts it off right here. So that's just a general idea of what the viewport is and what the scissors is. Now, all of Vulkan is about, making sure that the viewport and the images that arrive at the viewport, or the picture that Vulkan is trying to paint matches the dimensions of the viewport itself, right? And then you could cut the outputs, the pixels that are outputted to the viewport using the scissors feature. All right, so that's just a general overview of the viewport and the scissors. And next thing in the tutorial, we actually go through it in code and review it and see how it's done in the Vulkan API. The next thing that I want to quickly address is the Rasterizer. Now, again, in layman terms, all the Rasterizer does is it takes the fragments that you, the vertices that you declare to Vulkan, and then makes a fragment out of it. So the way I understand it is that you might have declared vertices for a triangle, right? So these are the 3 vertices that make up a triangle. What the Rasterizer will do is convert these vertices into a fragment. So maybe the fragment might be something like this, which makes a triangle. And then with the triangle, you can you could do certain things, like you could say, okay, connect these vertices via a line, right? So the Rasterizer basically dictates that, okay, we're going to connect these vertices with a line, and that line is going to be a triangle, right? So that's one way of looking at it, is that you have vertices and then you connect them with a line. Now you could also tell the Rasterizer, make the lines thicker. So I want the lines to be really thick. Okay? So that's also another thing that the Rasterizer will do. So now not only do we have vertices, but we have thick lines. And then you could also say, hey Rasterizer, fill in the region that these vertices enclose. So we might get some color or something that's filling in the region here. So that's the way I understand the Rasterizer to be, and I am sticking to it. So I also discussed this in the tutorial with actual running code. It's code that generates a triangle, and then we just kind of go through, you know, what each thing is doing, and creating, you know, manipulating some of the settings in order to get what we want. The last thing that I want to discuss is the idea of a render pass. So all a render pass is it's giving you options on how you want to modify the things that go on the viewport. So remember, we have this idea of a viewport, right? And then we might render images, we might render various things, colors, whatever, to the viewport. So in addition to the images that are in the swap chain, in previous tutorials I talk about a swap chain, and a swap chain is just a series of images. It's just a series of images that are eventually going to make it to the viewport, right? But along with the images, you might also want to add some color to the images, right? So maybe the image is displayed, but then you want to add some color. So the render pass basically allows you to make modifications to what is actually going to be shown on the viewport. So in the example that I followed, you add color. So you have render pass, you have a render pass, and then you have various sub passes. So the sub pass is where you actually add the color. And then if you had other things you wanted to add, you make more sub passes, right? And you declare this to Vulkan, and then Vulkan can optimize and say, okay, you want these 3 things to be done. We could, we could figure something out so that whatever is rendered to the screen is what you desire to be on the screen. And so, this would be our swap chain. I hope this is showing up on the screen, but this is our swap chain. And then we have our render pass, which adds things and eventually takes it to the viewport, which is what you see on the screen. So all render passes is just your ability, giving you options to add various things and modify various things, whether it be images or things on the screen. So it's sort of like render time. So upon render time, you could add other things to, give the triangle, for example, you have a triangle, you could give the triangle color. And the reason why it has color is because you have a color attachment, right? So a color attachment, right? And that's pretty much it. Now, there is also when you're declaring the render pass, it's standard Vulkan fare. It basically is driven by a thing called create info. So render pass, create info kind of thing. So you have this create info construct, and Vulkan to make a triangle, it's 900 plus lines of code, right? But a majority of the code in Vulkan is dominated by this create info structure, and all create info is you declaring settings to Vulkan. You're just telling Vulkan, hey, I want this option, I want this option, I want this option, I want this option, right? So a lot of the so-called complexity that people talk about with Vulkan is just giving you the option to, or not even the option, just giving you the requirement to declare all the settings that you desire in your application in order to get the triangle. So this create info thing is very important. Slash subpass. So even in our even in the triangle application, you have to create a render pass and a subpass to get the color, because we get the color with the subpass, right? But this create info construct it's very common. It's repeated many times for many different things in Vulkan. but a majority of the 900 plus lines of code is this create info construct here, right? Is this and of course the battle is, of course, you have to learn what these settings are, what it's doing, why it's important, what are the options you have to change it, and all of that stuff. So I just uploaded tutorial number 7, which goes through these things in detail on a code level. I don't think there is anything else that I missed for right now, but definitely below check out the link to the new tutorial. It's tutorial number 7. And then also remember to subscribe to the channel and